Today we're going to talk about inverse functions. You may have heard the phrase, for every action, there is an equal and opposite reaction. And that's very true with functions as well. Notice, this problem says the function of f of x equals x plus 8. Find the equation for f inverse. First, realize that that is not a -1 exponent. F -1 superscript of x means the inverse function. Now, some functions are small enough to where you can look at the original and tell what the inverse is. This original function says that the input x is added to 8. What is the opposite of adding 8? Well, of course, the opposite of adding 8 would be subtracting 8, because subtraction is the inverse of addition. So we could simply look at this equation, this function, and say the inverse of x plus 8 is x minus 8. So if it's a single operation function, you can just look at the problem and use the inverse operation. Some equations are not quite that simple. In this function, we have f of x is equal to x cubed exponent 3 plus 7. So there's a procedure that we would take here. We couldn't just look at this because of the exponent 3 and tell what's going to happen. First, in step 1, we will change the f of x notation to the letter y. That means we start off with f of x equals x to the third plus 7, but we will rewrite that as y equals x to the third plus 7. So simply change f of x to the value y. Then the next step would be to swap the positions of the x and the y in the original problem. So now we will rewrite this as x equals y to the third plus 7. Notice, no sign will change. Everything keeps the same sign. The reason we do this is the inverse is the opposite reaction. So in essence, the domain has to become the range, and the range has to become the domain to find the inverse. That means x and y switch their operations. Then the last step would just be to solve for the y. Notice the y has now been moved. So I would subtract 7 on both sides of the equation. I get x minus 7 equals y to the third. Then to get y by itself, I would take the cube root of both sides of that equation. So I end up with y equals the cube root of x minus 7. Now this cube root of x minus 7 is the inverse. Now, how can you tell if the graph of a function has an inverse? Remember when we were doing the vertical line test, the vertical line test is a test to see if you have a function or not. For instance, a circle is not a function. It fails the vertical line test. However, if we want to tell if a function has an inverse, we use the horizontal line test. If a horizontal line crosses the graph at more than one point, notice it crosses 3 points here, then it does not have an inverse. We cannot find the inverse function. However, if you had another function, let's say the cube function whose graph is given in the middle, and we draw a horizontal line through that, it crosses at 1 point. So yes, this function has an inverse. and that's inverse functions.